Hello, my name is Andres Rubio, and this is my Lab 1 constant velocity for Physics 2211. What the lab report will be looking like, consisting of an introduction, experiment code, discussions, and conclusion. The purpose of this experiment is to compare an observed example of constant velocity to a prediction through the experiment that I'm going to show you later on in the lab report. And this is going to allow us to understand the concept of constant velocity to a better extent, and also familiarize ourselves with tools such as Tracker and GlowScript, and in general help us to relate theory with experiments. Fundamental physical principles that we will be using in the lab report are Newton's first law of motion and Newton's second law of motion. The first being that if an object is in motion, it will stay at a constant motion unless interacted with another force, which we're going to see later on. And the second law, expanding on that, PHYS, so force is equal to mass times acceleration, and in turn, force is equal to change in momentum over time, momentum being mass times velocity. Through this lab, we're going to make a lot of discoveries, such as constant velocity being a linear relationship between time and position, and because of this, we can derive velocity as the slope of position and time. And as said before, with Newton's second law of motion, and first law of motion, velocity remains constant until an external force affects it. And we'll also see later on in the experiment that a key difference between theory and reality is human error. Now we'll be getting on with the experiment. For the experiment, our experiment consists of pushing a marker and measuring the velocity at which it moves at constantly, and the marker being the system, and the surroundings being gravity, friction, and push force. And for the initial conditions, we have to make sure that the highlighter is pushed in the center so that it doesn't add a y component to the velocity, and that it's pushed with enough force to allow for continuous velocity and negligible friction. And for our assumption, we have to assume the floor is completely level so that the x component is the only component that really matters. Actual visual experiment with the marker being pushed at a constant velocity with the ruler as a frame of reference, and you can see that there are already about 20 nodes of data that we have at the bottom right, and you can see at the top right that there's a constant slope, which means there's a constant velocity and a constant relationship between position and time. We are moving on to the code that we wrote to see if the prediction of the experiment that we just performed is similar at all to the reality of it. Here we see what I consider to be the most important part of the code. I split it up into two parts so that it's easier to digest. The purple part on the top, which is basically details about the motion of the highlighter, the initial position, velocity, initial time, and time intervals. And the orange code, which is essentially just updating the position for a second, around, I'd say, 25 times. And you can see there F net is 0, so the velocity will be constant. We see our prediction models. So as you can see, the output looks very similar to the way that our marker moved in a straight line. And we see the data points that are going to be later discussed in the lab report there. And then in the right, we see the relationship graphs between time and position, and then time and velocity. And we can clearly see that the bottom time and velocity have a constant relationship, and time and position have a slope, constant slope. We're going to be discussing some further points. There are two graphs. The top right is the prediction that we just recently performed for code, and the bottom right is the tracked motion. And as you can see, we got the same general slope and look, so we managed to take control of the variables pretty well. But you can clearly see that the bottom right has more nodes, and it also starts a little bit earlier, and that's just all user error. And here are some possible errors that we may have made. There are other external forces like friction of the floor and air resistance, tracking error. I could have made some errors when placing the nodes, and a shaky camera by the cameraman. Now, here are some potential questions. What if we flip the orientation of the axes in the tracker? So essentially, we record in the negative x direction instead. I think that the slope of the graph would just be negative essentially because we are counting positive for negative, so it would just be flipped. And the other question, what does it mean for the net force to be 0 in your model? And considering other forces, like earlier we said that there are external forces like friction and air resistance, the push from my teammate would probably counteract that pretty well, and that's what kept our model so consistent with the theoretical. Thank you for your time, and I hope you were able to learn something about my lab report.